began from the rocks, water, gases, and other compounds launched into the inner solar system by the fountains of the great deep. Of course, some ejected bodies did not combine to form larger bodies. These smaller, rocky, sometimes metallic bodies are called meteoroids. Those that have returned to Earth's surface are meteorites. Studies reveal that meteorites contain a variety of surprising materials which have experienced a unique and turbulent past. The following items have been found in meteorites: chondrules, salt crystals, water, limestone, which only forms in liquid water, DNA components, possible cellulose, sugars, living and fossil bacteria, terrestrial-like brines, excess left-handed amino acids and heavy hydrogen, and Earth-like minerals and Earth-like isotopes. All these implicate Earth as their source and the fountains of the great deep as the powerful launching mechanism. Meteorites can be divided into three classes. 95% are stones, rich in silicon and the mineral olivine, both common on Earth. 4% are irons, which are an iron-nickel mixture that was initially molten and experienced uniform heat of at least 1300 degrees Fahrenheit, as evidenced by their unique Widmanstatin pattern. Finally, 1% are an intermediate class of stony irons called pallasites. Pallasites formed from a molten iron-nickel mixture which seems to have been injected into or mixed with fragments primarily of olivine. The mixture of metal encasing olivine during the flood in the inner solar system when the bodies were much closer together. Sea of high-velocity debris, water, and gases from Earth during the flood also explains much of the Moon's surface topography we see today. The Moon is gravitationally locked so that only one side ever faces Earth. The smooth dark spots on the Earth side of the Moon were once thought to be seas, so were called maria. The dark maria are actually a remnant of a great deal of melted rock. The far side of the Moon is much different. While the Earth's side is relatively smooth, the far side is heavily cratered as though impacted by many small objects, primarily from debris kicked up by larger impacts on the Earth side of the Moon. Again, here is the view we always see from Earth, and here is the far side view that, while cratered, has no dark maria. While the Earth side is relatively smooth from the maria, the far side has been heavily cratered by many small impacts. The Earth itself tends to shield the Moon's near side from impacts. Did several asteroids impact the Moon while at the same time missing Earth? While not a complete impossibility, the expectation would be for large impacts to favor the far side of the Moon where it is not shielded by the Earth, or at least for impacts to be more evenly distributed about the Moon's surface. The far side of the Moon is always open to incoming impacts. We might imagine that with the Moon being so far away from the Earth that the Earth would be a poor shield for the Moon's near side. That is because we tend to think of shielding in terms of straight-line impacts, somewhat like seeking cover from bullets. So in this scenario, there seems to be many available angles where incoming objects could still strike the near side of the Moon. However, unlike bullets at short range, the large gravitational pull of the Earth greatly affects trajectory. The Earth's gravity makes striking the Moon's near side by first passing nearby the Earth much less likely than we may first imagine, even though the Moon is physically far from the Earth. The shielding effect of Earth's gravity becomes even more apparent when we remember the concept of gravity being a function of an object's mass, which stretches the fabric of space, making a gravitational well. When this concept of gravity is visualized, we can more easily see how unexpected it would be for an object rolling left to right on the gravitational well to strike the near side of the Moon. It is possible, but certainly a great deal less likely than striking the far side. Inbound objects moving right to left have a much better chance of striking the Moon's far side. What if the debris that struck the Moon's near side came from Earth? Gravity measurements of the Moon's surface confirm several areas of highly concentrated mass, likely due to very large objects that impacted from the direction of Earth. If these were random asteroids from space, why are they all concentrated on the Earth side of the Moon? How did several asteroids impact the Moon while at the same time missing Earth? Assuming the Moon is billions of years old, researchers find that the Moon remains unexpectedly hot, measuring very high heat flux still emanating from its surface, and finding a small molten core. In addition, the Lunar Prospector picked up signatures of the short-lived radioisotope radon-222, emanating near two craters on the Moon's leading face. How did radioactivity develop inside the moon? Hydroplate theory proposes that the mass concentrations, the unexpected heat, the presence of radon-222 gas, the remnant water ice in craters, and the unique topography differences between the moon's near side and far side are best explained as a result of a recent bombardment of the moon during the flood as materials were launched from the Earth's deep fountains. Dr. Robert Brown, professor of astronautics at the United States Air Force Academy, calculates that the debris would have reached the moon's sphere of influence outlined in yellow approximately 5 days after exiting Earth's atmosphere. Ejected debris then began impacting primarily on the leading face of the moon's near side. As discussed in the hydroplate overview and radioactivity presentations, the ejected materials would be expected to contain both water and many radioactive isotopes, some of which continue to decay into short-lived radon gas today. The recentness of this flood event explains why these short-lived materials are still detected on the moon's surface. After millions of years, short-lived deposits of ice in these craters would have long since dissipated. Hydroplate theory also explains why the far side of the moon does not have mass concentrations, or mascons, nor the dark maria that we see on the Earth side. The far side was sheltered from direct impact. However, smaller, lower velocity debris lifted from the surfaces of the near side's direct heavy impacts could not escape the moon's gravitational sphere of influence, which pulled it back. This produced many secondary impact craters all around the moon's surface. These secondary impacts would have struck the near side of the moon as well. However, since the Maria basins remained hot and volcanically active for a time after the initial impactors hit, many of the secondary impacts on the near side were absorbed and quickly resurfaced, while the cold, inactive far side's surface preserved the many craters. The added mass from these impacts would have changed the moon's orbital characteristics